Hello! In this video we're going to be looking at exact values and compound angles. Now, in a previous video I showed you how you could, using Pythagoras and various other things, find out what we call exact values for these angles 0, 30, 45, 60 and 90 for a right angle triangle. Now you might ask, why these exact values? Well, in olden times there was a feeling that all numbers could be expressed as a fraction, that is, one number over another. There were no theories or thoughts regarding what we now know today as irrational numbers. These are numbers that cannot be expressed as a fraction or one number over another. Now, these irrational numbers can, however, be expressed as a square root, or in a way that they don't need to be calculated out specifically to a number. And this is what we have here, and these are what we call exact values. So we don't work them out to a number, we just leave them in this root format here, and they are the exact values. Anything we work out with a calculator is an approximation, and we just leave them how we are, which means, of course, for these particular angles we don't need to use the calculator. We can do our maths just based on these irrational numbers like root 2 and root 3 and so on. Now, we also have a series of compound angle formulas that we can show you how these develop and how they're proven, but in this case here I'm not going to, because it's not required for what we want to do. So the compound angle formulas are as I've written here, and you can see there's some patterns involved there. Sine A plus B is sine A cos B plus cos A sine B. Look here at sine A minus B, it's just the same except it's negative. Now cos A plus B is cos A cos B minus sine A sine B, and you can see the negative is the actual opposite. Now, I can remember in my days at school we actually had to memorize these for our exams, these compound angle formulas. I'm not asking you to do that, they're provided here for you. So there are certain ways that we can use these, and here is one type of situation where we can find the exact value of sine 75 degrees. Now, just looking there, you can see that 75 is 30 plus 45. We have down here a compound angle formula that enables us to work out what sine of A plus B, or sine of 30 plus 45 is. And so we write that in here: sine A plus B equals sine A cos B plus cos A sine B. So sine 75 must equal sine 30 cos 45 plus cos 30 sine 45. So we just put in the appropriate values here. Sine 30 is a half from our table over here. Cos 45, 1 over root 2, plus cos 30, which is cos of 30 is root 3 over 2, and sine 45, 1 over root 2. And there we have the two fractions. Now we know that the bottoms are the same, they're both 2 root 2, and 1, so the bottoms, multiply the bottoms, multiply the tops, so 1 times 1 is 1, 1 times root 3 is 3. Two bottoms, or the denominator, are the same, 2 root 2, so we can add the numerators, 1 plus root 3. Now that's as far as we can go with that. We can't make it any more exact than that. So that's the answer, 1 plus root 3 over 2 root 2. So let's first of all get rid of that one, and let's have a look at another one. Here's another one. Find the exact value of sine 15. Now 15, of course, is 45 minus 30. So using sine A minus B, sine A cos B minus cos A sine B, sine 15 equals sine 45 cos 30 minus cos 45 sine 30. 1 over root 3 times root 3 over 2 minus 1 over root 2 times 1 over 2, or a half. Again, we get root 3 over 2 root 2 minus 1 over 2 root 2, and we know that the bottoms are the same, so we can subtract the tops. Root 3 minus 1 over 2 root 2. QED. Quite easily done. Now we have this one here, which is a little bit different. Find the exact value of sine A plus B when sine A is 5 over 13 and cos B 3 over 5. Now, as we know, these represent the sides of a right angled triangle. So in the case of 5 and 13, we know the angle opposite A is 5 and the hypotenuse is 13. And using Pythagoras, we can see that 13 squared is 169 minus 5 squared 25 is 144, which is actually 12 squared. So we can see that we have there what's known as a 5, 12, 13 triangle. And then of course the 3 over 5, cos B, 3 being the adjacent, 5 the hypotenuse. We know of course this is a 3, 4, 5 triangle, the most famous of all Pythagorean triples. So here we have used two Pythagorean triples, and there are quite a number of them. The 3, 4, 5 triangle and the 5, 12, 13 triangle. So now it's just a matter of we know our sides, we can work out the exact value of the sine, cosine and tangent of angle A and B. So let's go to the formula. Sine A plus B equals sine A cos B plus cos A sine B. In this case here, 5 over 13 times 3 over 5 plus 12 over 13 times 4 over 5, which is 15 over 65 plus 48 over 65. The denominators are the same, so we can add the numerators. 63 over 65 is the exact value we're looking for. And that's as much as we're going to investigate these exact values and compound angles for now.